As you can see, it's currently working. Unfortunately, I had to switch to a non-continuous standard servo because my continuous one had a problem with it with one of the gears. But yeah. The three primary components of the circuit are a continuous servo motor, an LDR, and the Arduino Nano. The servo has 3 pins, the power, ground, and signal pin. The signal pin receives commands from the Arduino through the write function in the servo library. The parameter used in the write function is the angle at which you want the motor to move to. However, this input is interpreted differently depending on the type of servo receiving this information. A standard servo operates normally and will rotate the motor to the angle that is in the parameter of the write function. A continuous servo will instead take this angle and use it as a measurement of speed and direction. For example, if the function is servo.write 30, the servo will rotate clockwise at a fast speed as it is very close to 0 degrees, which is its max speed. If the angle received is 90 degrees, it will stop motion completely, and if it receives an angle greater than 90, it will rotate counterclockwise. The light dependency in the circuit comes from the LDR voltage divider that is read on analog pin 0 here. A well-lit room is about 70 in the serial monitor when constrained to a value between 0 and 180, so the servo is set to turn in an if statement when the LDR reading is about 30. The 5 main components of a servo are in order: a pulse converter, a comparator, a motor driver, a DC motor, and a potentiometer. The pulse converter is what determines the speed of the servo, as it is what reads the pulse signal from the Arduino. The pulse reading is as such that if the pulse is short, the motor goes left, and if the pulse is long, it goes right. The inputs into the comparator are the signal pulse from the Arduino, as well as the reading from the servo-turned potentiometer. The DC motor has a north and south configuration that is turned in a magnetic field by 2 H-bridge operated coils. The DC motor then turns a gear train with 8 gears that converts the high-speed, low torque of the motor to a low-speed, high-torque servo gear that allows for precise movement. Finally, the movement of the servo causes the potentiometer inside the servo to rotate as a variable resistor. The voltage left over from the potentiometer is inputted into the comparator, which reads both the signal and potentiometer voltage. These two values are compared, and if the difference is greater than 0, then the servo will rotate until that difference is as close to 0 as possible. Thank you for watching.